Okay, thanks, Bill. Yeah,
Okay.
can you hear me?
Yep. You're good.
Okay, good. Sorry, I was getting mixed up there for a second. So, appreciate you having me again. We're going to be talking about performance tuning tips in Wakanda, how to really get the most performance out of your applications. We're going to be going through some, I guess, what I would call low-lying fruit today. Let me just get my slides going here. But we should start with a brief description. What's Wakanda? So it's a high performance, at least after you watch this webinar, it's a high performance stack. It's JavaScript end to end, and it's based on web standards. Has a NoSQL relational object data store. So it's an object data store that you can easily work with related data. It's focused on business applications, and it's designed to make development more productive, would be its #1 goal between Studio and the server. All aspects are really striving to make you as productive as possible. So why should we care about performance? Well, the reality is I don't think I need to answer this, but when it comes to web applications, fast and responsive is always better. I would encourage you to not be complacent and really care about performance. Now, there's always checks and balances to that. You don't want to be so obsessed with performance that you completely ignore programming efficiency and development ease, as well as user friendliness to the next developer who takes over your project. But don't leave low-lying fruit or easy fixes unchecked, or always verify that you're doing things as well as possible, because you can always go back and tweak things afterwards. So you do the best you can up front, and later on, if you find that there's bottlenecks, you can always optimize when load becomes a more prominent issue. So general categories today, I think most areas of efficiency and performance can fit into these categories. You have hardware capability and setup. So that's what hardware are you using, and how are you setting it up? Do you have it configured properly, and that type of thing. The next one is effective use of your server resources. So you have the nice big powerful server, and are you using those resources effectively? Next one is network efficiency. How many times are you hitting the server? What type of data are you sending? Is it efficient? Is it effective? And then the other thing, when you have a platform like Wakanda, you have modern browsers today are rich clients. They all have JavaScript that you can utilize on the client side to help reduce the load on your server and get a better performing application, both from the perspective of load on your server and user experience on the client side. So let's talk about hardware. The main points to consider: Wakanda scales vertically out of the box. So you always want to think of scaling vertical first and then horizontal. High-end servers today can do a lot of heavy lifting. Vertical scaling is as easy as that. Buy a bigger machine. Wakanda automatically out of the box will take advantage of multi-core, multi-processor machines. Horizontal scaling takes takes more engineering effort. So I'd say scale vertical first, and then look into horizontal scale. Don't cheap out on RAM. This is a very common one I've seen in the forum. I've seen all over the place. Everyone wants to save $1, and I can understand that. Wakanda does run on a 512 micro instance on Amazon, for instance, or another virtual private server. However, it's not ideal. So I'd say if you're testing, if you're just doing the bare minimum, sure, put up a micro instance, keep it inexpensive. But when you get into real production, it's never a bad idea to invest the proper amount of resources into the right hardware. So SSD can be a real big advantage, in particular when your database grows. Access time is the real key performance differentiator with SSD. So as you get into a really large database and you're frequently accessing one particular entity in the data store, this is where SSD will really shine. So for larger DBs, I'm going to suggest the default cache setting is 200 megabytes. You're going to want to watch that. There's currently no real hard and fast rule to what cache matches what size of data store. What I would say is this is more knowing your application and tweaking this particular setting, but it can have a dramatic effect, in particular when you're into large databases. So the one I would, real world example I would say here is you're better off using one powerful server for 4 projects instead of using 4 weak ones with 1 project each. Grab a nice big server and use it to its full capacity, because you're gonna take Wakanda has a certain minimum amount of resources it needs, and then everything on top of that is going to help it scale. Let's talk about resource usage. So that you've chosen your hardware, you're confident there, the first thing you want to do is use those resources properly. So there's an easy win. Turn off your debugger. When you're in deployment, turn off your debugger. JavaScript heavy server-side processes will be the biggest benefit here. So reading, writing to the data store, you won't see as much of a difference because those are C++ actions. But when you're doing processes in JavaScript, you'll see a big difference. Studio starts debugger by default. So if you are launching it on your server through Studio, you want to watch that. It makes sense in the scope of Studio to start the debugger by default because we're assuming that you're developing the application. So let me show you an example of the kind of performance gains you can get with this. I'm going to open up a project here. It's this debugger one. And I'm going to start the server in Studio. So when I was a new user, this was one of the first mistakes I made, was I started up the server on my co-located Mac, and I was off to the races. Now I've got these each on a different port, so I'm just checking the port. This one's on 8081. So I'm going to go to the browser, and let's hit that index page. So this project is the Wakanda playground that I've got on my GitHub account. It's github.com/mccarville, which is my last name, and then this one is Wakanda Playground, and it has a generate data function. So let's generate 500 people, and I have a timer in here. It's going to pop up with how many milliseconds it takes to access 500 people, or to create 500 people. And maybe I should have done less because this will take a bit. Actually, you know what? I'm going to do a better one. This here, I didn't label the button. This is actually a button that's going to run a JavaScript heavy script. I've made a ridiculous script here on the server side that loops through 300 times, does a bunch of stuff with arrays that makes no sense, and what it's meant to do is just to consume resources. So let's give that one a try. It's actually a better example. Let me double check this. I would have expected that to come up by now. Let me just take a quick look and make sure I've got the timing working. Okay, I don't. I have a debugger here. So what I'm going to do is I'm going to run that. I'm going to do a var start time equals new date. And then in the onSuccess, so this is after the method has finished, we'll do var end time equals new date. And then we'll do alert. We'll just alert the milliseconds. And it will be start time, or sorry, end time minus start time. Okay, now we should get an alert. So let's go back to the browser. I should have tried this ahead of time. So I'm going to move on. Essentially what you'd find when I did my test anyhow was this actually improved the speed 10 times when you turned off the debugger. And I apologize that that didn't work properly. Oh, that would be it right there. Try it one more time. Okay, so we'll move off of this example. What I would say, so basically when you get into this type of scenario is you want to turn off your debugger, which is done by going run, stop debugger, and there is also a way to do that in your management console. So if you go to 8080, your debugger options right here. So this is how you would turn it off and get full performance. So that's the first easy win. Make sure your debugger is turned off. Second easy win is to utilize indexes in the right places. If you're querying a large number or you're frequently querying data, then that's a good place for an index. Indexes can slow down write operations, so use them only in the appropriate place. And you really have to strategize and think of how your data will be queried to avoid overlap. So for instance, if you're querying on a last name and then subsequently querying on a first name, if that's always the order and you're never querying first name by itself, you may only do an index on your last name because that will reduce the scope, which would make the first name query not necessary for an index. So if you have that situation where there's always overlap, you don't need to duplicate the indexes. So just think of it strategically and go for it. When you're selecting the data type, you want to balance convenience with performance. So for instance, I'm going to show you an example where I have a gender. And in this example, it makes sense to use a Boolean. Now, I would say there's some cases where using a string, for instance, if you have a category data store class, sometimes it makes more sense to use a string rather than take the effort and change them to an integer and have one represent this category, two represent that category. And that's again back to the example of what effort should you take. I would say you start on the side of convenience, and as your application grows and requires performance boosts, you can then look at doing optimizations like the one I described there. So let's go into this project, and I have a script here in required.js that generates data. So we'll try, this is, I believe, let me check the port on this one. So this is port 8082. So let's generate 100 people. Or let's generate 500, just so we have enough time here. And you can see the time it's taking. What I'm going to do is I'm going to actually optimize this scenario. Okay, so we've got 22104 milliseconds to make 500 entries. So that's unacceptable. Let's do some optimizations. The first optimization, if I look at my model, this model, is we have a person here, and like I said, we have a gender. The first optimization we can make is we can change this into a Boolean. So if we go to required, the first thing I'm going to do is I'm going to search for gender and see all instances of where gender is, and we're going to fix those up. Okay, so it assigns it a Boolean, and here's where it assigns it text, so we're going to take that out. We're going to take this text instance out. We're going to assign it the Boolean in the save. And up here, I'm going to change this to the Boolean value as well. So a female is equivalent to 0 in this function. So basically, I've taken all of the writing mechanisms and turned them into Boolean. And the next step I would do is I'd go to my model, choose my gender. Now I'd have to do some conversion for my previous data, but for today I won't. So there, now we've done that optimization. We now have a Boolean. If I go back into required, here's a good way to look for inefficiencies related to indexes. I'm going to look for query. You can see here I've got a query on last name and gender. The other one you'd want to look at is find. So I have a find on last name and if a spouse exists, which is a relation entity, so I can't index that. So I've got last name and gender, both are part of a loop for each person that's made. So this is a great place to do an index. So all we do for that is we just go back to our model, we get last name, and this would probably be best with a B tree. And then our gender will go to a cluster. We'll save that, and I'll restart the server. Okay, we'll start it up again. We'll go back to the browser, and we'll do the same thing, 500. So we were 22 last time. Let's generate 500. And you can see significantly reduced the time to create those entities, because what was happening was we were doing a query to find the mother and father for each person as we created it. So we were searching through, I think I've got over 30,000 entities in here right now. If I go into server side here, let's just take a look. So yeah, 26,000. So every time it was creating a person, it was querying through 26,000 people to find a relative. So that was right there, significant gain just by adding indexes in the right place. So that's another easy win, is indexes. Calculated attributes. Calculated attributes are an excellent tool used in the right context. There can be too much of a good thing. It's the classic case again of balance of convenience versus performance. There's low overhead for simple calculations. So you know, the classic example is a full name. Absolutely no problem there. The best way to evaluate for the suitability of a calculated attribute is how often will the data change, and how complicated is it to calculate. And between those two, you can make a judgment call Full names potentially get changed frequently. It's a very simple calculation, so it makes sense to do it there. One thing you want to pay special attention to with calculated attributes is querying. If you don't use the onQuery event, what happens internally is it actually assembles the calculated attribute as it's querying through the table, which would be, as you can imagine, quite dramatically slow compared to a customized script in JavaScript that you develop. And there are resources on how to put together an onQuery event for a calculated attribute, but you'll save yourself monumental amounts of processing and time doing it this way. If you need calculated attributes, the way that things work right now on the client is when you're using a data source, it will load an entire entity. Or if you're displaying them in a grid, it's going to load all attributes. So if you have set many calculated attributes that are heavy in your entity, that can become an overloading situation. So if you have an abnormal situation where you do have abundant use of calculated attributes, there's a couple ways you can go around it. And again, this is on the case of architecting if you know there's going to be a performance bottleneck. So this would be an example of out of the box what you would probably do. You'd have your regular attributes, and then say we have 4 calculated attributes here. So as you access this from the client, it will send all of these calculated attributes and be working with those calculations. So if you were to put this in a giant grid and they were complex calculations, you might get some performance lag there. The first option that you can exercise is you can use an extended data store class. So you could, because you can put calculated attributes in an extended class, perhaps you have a specific time when you need to access your calculated attributes in a list or other, is you can leave them out of your base class, put them in an extended class. When you need them, you access through this extended class, and when you don't need them, you access through the base class. And that's one way to get out of the automatic loading. The other option is you can create getters and setters for the calculated attribute instead, and this keeps it out of that automatic entity loading mechanism as well. So these would be 2 options right now. Of course, going forward, we're looking at options to specify which attributes are loaded or not loaded, but in this immediate case right now, this is 2 workarounds that you can use to make your structure more effective and perform better. Workers. I hope to have had an example together today for this. I didn't end up finishing in time. But workers are useful for one particular instance where the server inherently is multi-threaded. When you're taking in web requests from many browsers, it will fully utilize all the processors you have. We've talked about that. Where workers come into play is for one request that's perhaps very complicated. Think of something like generating a report or doing some sort of mass operation. What you can do is you can actually break that up into several workers, and you'll get full utilization of a multi-threaded environment. So a worker allows you to create threads. So say, for instance, you had a report. You could break the report calculations and generation into 4 parts, have them go and be processed on in several threads utilizing the multiprocessors, and then take those results, combine them into one report. So workers are a great thing for, like I said, long-running processes. You can also use something called shared workers, which is a different topic but along the same idea. So network efficiency, this is another topic where you can make a lot of performance gains. The number 1 rule is just hit the server less. So when you have something like categories or let's say settings, or if you had, let's even take current user. These are all good ideas for when you could store data locally in a variable and not hit the server every time. So when you want to check if what the current user's name is, you have it stored locally. You don't have to hit the server for that. When you are bringing up or selecting out of a combo box that has a list of predefined categories, those should all be kept in an array or an object locally and not referenced to your quotes category data store class on the server each time. I have an example of uh, this working, and the example I have is another great place where you can be more efficient here is do batch updates when possible or when it makes sense. Let me give you a typical example. I'll go to another solution here. I'm going to start the server again. So I have an index page here, and I have two. Let me show you the model. So it's very simple: orders, and order items. So obviously a one-to-many relationship. Each order has many order items. I'll start the server. Just want to check the port on this project. It's around 8083. So go to the browser. And these two are essentially going to do the same thing. What I'm going to bring up is the developer tools, and we're going to look at the network. So you can see, sorry, we have to reload. I'm going to clear this out. So let's look with maybe the traditional way of doing things. Is this was an auto form. I'm going to add a new item here. Item 1, price, and you can see. So it updated on this server. There's a round trip. Item 2, item 3, and you can see it's hitting the server each time. And let's see what happens when we remove. Again, we're getting a network. So a lot of network activity happening here. What I've done on this side here is I've actually created, let me show you the actual page. So these are using data store class data sources. What I've done here instead is I'm using local data sources for everything. So this is the order items object, or OBJ, right here, and the order itself is this order object. So when we go back to the browser, I'll show you how this works after, but let me show you the network effect first. So here when we add a new item, let's clear this out. We're going to add a new item. This will be 1, 1, 1. No network activity. 2, 2, 2. 3, 3, 3. But very similar user experience. We can remove them. And again, there's no effect on the network whatsoever. So what we do then is we have a local object here. This is what I mean by batch updating. So if we go to this Save Order Good button and we look at the script, you're going to see what we're going to do is we're going to create an order object. We give it the 2 properties, and then we use our order items object array data source, which when you reference it as a variable is an array type, and we include that in the order object. Then we send all of that to a save order function on the server, which is right here. So I've got a debugger call, I believe, in here. Yes, I do. So when we save this order, we should get the debugger up. And there it is. So what we've got is in one request to the server is we have our entire order object. So now we can take, we can process the order and all of its line items here in the data store class method, and we've only made in total one trip to the server. So that's what I mean by just being effective with the amount of trips you make to the server can make a big impact. You imagine if you had 500 or 1,000 or 10,000 users entering orders, this could have a tremendous impact on the performance of your machine. So my last point here, I think, is use the browser. Business rules should always be enforced on the server. So, when we talk about securing your data model and creating business rules, absolutely, those need to be on the server. They need to be enforced without question. But the browser can lessen the load. So if you have, say, UI-based rules, that could be validating formats, validating input data. It could be anything that has to do with the user interface. You can build a lot of these of your business rules into the UI, provided you follow the golden rule that you don't count on it. It can be a good filter to lessen those hits to your server, but make sure you're always duplicating those business rules on the server so that you can be sure what's getting in and out of your data store. So that's the low-lying fruit. So that's cool, but now what? We're going to be really expanding on best practices. We want to provide you a lot of information to make sure that you're able to develop applications in Wakanda with the best performance possible. So we're going to be getting into benchmarking and really providing you comprehensive studies of different use cases and different best practices. So we'll be rolling those out frequently. I'm going to say, I'll likely will have some information for you within the next month. It'll be our first crack at it, so we're going to look for feedback, and we really are interested in hearing what you think. So that's the webinar for today. Bill, do we have any questions?
Not at this point, no. So if anyone has any questions, now would be the time to submit those. Give a couple seconds for that. Okay. All right, so here's someone asking about the future, I guess. What are performance enhancements in 4.0? When can we expect it? Will there be additional stabilization releases?
Well, performance is something that we always strive to improve and tweak constantly. Every release, we're doing things for that. And this is one of the points that I want to cover is we're going to get a lot better at communicating not only the really interesting front-end features such as widgets and features in Studio. We're going to get a lot more intelligent about showing what we're doing in the guts of the server to enhance performance. So I guess the answer to that question is version 4 had many enhancements for speed, for performance, and our goal going forward during version 4 is to demonstrate those. And then as we progress forward, these will be more public and anyone who's interested. And the other thing I would say is if you feel there's a situation, a use case where performance is not meeting your expectations, please get in touch with us. It could be a question of technique from the development standpoint, or it could be an opportunity for us to make an improvement in the server. So we're totally we welcome all of those suggestions and concerns.
All right, so another question. Do you have any experience with indexes on UUID fields?
Yes. What I would say about UUID, so if you're talking about a primary key, this is where I guess maybe they're asking what type of index, and I think,
The follow-up question to that was any recommendations on kind of index to use?
yeah, good question. Let me take a look here. Um, the best person to ask is going to be Laurent. So what I'll do is I will ask him and and see what he says. That's probably the best thing. So this webinar, what I'll be doing is I'll be posting it in the forum like we did the last one with an index, and I'm going to encourage you to add questions to that thread. So this will be one question that I'll address in the forum.
All right. What about client-side performance? Are there strategies to speed up loading widgets, big grids, etc.?
Yep. Well, I should have mentioned that that is part of Wakanda 4, I believe. I have a hard time keeping track of what's what, but we're doing a ton of work on the loader process, loading the framework into the browser. We're able to now modularize it, and you can load exactly what you want. So, say for instance, you wanted to put a jQuery UI front end on, you can only load in the data provider or whatever sections you want. So that's a huge focus right now. I know Ricardo has a really exciting project going on with that particular use case. So the other thing is with redesign of the widgets, it's not only going to be widgets, it's we're going to be looking at everything from data sources to widgets and making them as efficient and lightweight as possible. So you'll see a lot of improvements for Wakanda 5 in that regard.
All right. So we have another question about server performance among different platforms. Do you have
Yeah.
any knowledge on which is best, Windows, Mac, Linux?
Uh, we don't have any concrete facts. This is definitely something we're going to benchmark. I was talking to Laurent about that actually just yesterday, and he basically told me that yes, there are differences, and there's performance differences based on their file system and the way that the OS mechanisms work. Um, However, I would say his advice to me was um, I guess he made a comment to me because I had a Mac server, and he said you might want to check on that if that's the best way to go. But I think he was talking from some experience he had quite some time ago, and operating systems update all the time. So what we're going to do is we're going to actually benchmark that exact scenario. Now it's a little difficult to do because you need to match hardware and that type of thing, but it's an interesting question for sure. And I would say right now I have a Mac server. It seems to run fine, but I would tend to stick to probably Linux if I were doing a production server.
Okay. That's all the questions it looks like we have for now. So with that, thank you very much, Greg. Great as always. For everyone else out there, if you have any suggestions going forward for topics or any ways that we can improve webinars, I'd love to take your feedback. You can email me at bill@wakanda.org. Um, any suggestions would be gladly accepted. So thank you for coming, and thanks, Greg, again, and we'll see you
Okay,
next time.
thanks, Bill.
Bye
We'll
bye.
talk to everyone soon.